Hello everyone. Today we're looking at a problem in which we have an oscillating spring moving in simple harmonic motion. So let's get straight into the problem. The prompt reads, starting with the respective restoring force, derive the period of a spring pendulum. Alright, so let's just take a look at the problem, or let's just take a look at our restoring force equation, which is going to be ma, which is just our equation for force, and then we have our equation for spring force, which is negative kx. And from here we want to find our period in seconds of a spring pendulum. And the way we're going to do this is by using the displacement function in terms of time of a spring, or rather of a oscillating motion, which we know is amplitude times sine or cosine omega t. It doesn't matter. In this case, we'll use sine omega t. Alright, and from here, we have acceleration on this side, so we want to find acceleration on this side as well. And the way we're going to do this is by taking two derivatives of this function. So the first one is going to give us our velocity in terms of time, which will be it'll be positive a cosine omega t times the derivative of the inside, which is just omega. And when you take another derivative, you get the acceleration in terms of time, which will give you negative a sine omega t times the derivative of the inside again, which is omega, times the omega we had from last time will give us omega squared. So our acceleration in terms of time is a sine omega t omega squared. But as we can see here, we have an a sine omega t in the bottom, and we also have one in the top, so we can just call this term right here x. So let's rewrite this. Our acceleration is negative omega squared x. And so now that we have acceleration on this side, let's find acceleration using the restoring force. All we have to do is divide both sides by m, and that'll give us a is equal to negative k over m times x. As you can see, we have two pretty similar looking equations here. So let's set them equal to each other. Negative k over mx is equal to negative omega squared x. From here we can get rid of our x's, we can get rid of our negatives, and what we want to solve for here is omega. So since we have omega squared is k over m, we know that omega is simply square root of k over m. And from here, our last step is to use our omega equation that has time in it, or period in it, which is omega is equal to 2 pi over t. And you can remember this by remembering that omega is angular velocity, which is radians per second. Here we have 2 pi, which is 2 pi radians, one complete revolution in a circle, and we have t, which is the period of one revolution in seconds. So if omega is 2 pi over t, our t is simply going to be 2 pi over omega. Or 2 pi times 1 over omega. So our final answer for t will end up being 2 pi times this square root flipped, which gives us square root of m over k. That's all I have for today's video. I hope you guys are able to solve this problem on your own now, and make sure to tune in later for more physics tutorials.